Okay, YouTube, I've made a video here to solve two problems that I find on the internet. One is there's a lot of regurgitation of information. And by that I mean people just read somebody's article, they paraphrase it, and they pass it on. But there's no original knowledge. So this video is about creating some original knowledge. Second of all, there's a lot of fear marketing in the world. People put infants inside of tires to sell you tires, or they tell you if you don't do this, it's going to cause all this damage. And it happens certainly with irrigation systems and pool plumbing. They say, you got to spend $500 to have the right blower to blow out all the pipes, and otherwise it's going to break and it's going to be expensive. And it will be expensive, but you might not have to go to that length. So I have a lot of questions about what it takes to break a PVC pipe. First of all, how vulnerable are they actually to freezing? Is it something that's going to happen right away, or is it kind of a rare thing? What amount of water causes breaking? If I partially fill the pipe, is that enough to break the pipe? What concentration of antifreeze makes a difference? If you're going to put antifreeze in the pipe, can you do 10%? Do you have to do 100%? Next is the amount of breakage that you experience related to the temperature, proportional to the temperature? Does the diameter of the pipe matter? Are larger pipes stronger or weaker? And PVC versus poly, there's black poly pipe, and usually that's pretty good. So what I did was, last fall I did this, I lost my video of constructing these, is I took a bunch of pipes and I assembled them and carefully measured the amount of water. This one's got 10% water. It's almost empty, and I put that out there. And then I have other ones with, I think it was 25, 40, 60, 75 and 100. I'm not exactly sure, but something like that. And I made a bunch of these pipes, and then I stuck them out over the winter to see which ones broke and when. So I did these pipes, and these are, I'll find out what the diameter is. I'll put it on a note. And then I also did larger pipes, same thing. What I also did was I put different amounts of concentration of 100% pipes filled with 100% water, different percentage concentration of antifreeze to see how that reacted. And finally, I also did a couple poly pipes just to see how they survived. So that's the video, and I'm doing what I call a Mythbusters quality study here. It's not lab quality, but it's certainly pretty good enough to answer some questions. Okay, so here's the back of my house. We just came off of a super cold period of time. We had sub-zero temperatures Fahrenheit, and I'm going to be putting the pipes out here. I'm kind of in a little bit of a rush, so I'm going to do it quickly, and maybe I'll come back and change it. I do want to cover it. I'm looking for a nice spot here, a nice flat spot. I do want to cover it from a UV perspective. And I'm going to try and make them as level as possible. Tonight we're not expecting sub-zero freezing, so I'm not horribly worried about anything breaking this evening. I'm going to sort them by percent full. It does look like it's a little off level, but like I said, it won't matter tonight. Pulling out some antifreeze ones. There's a 90% water, 100% water, 60% water, 40% water. I forget if I have a 75. There's a 10% water. Let's see. Looking for any more waters. Nope, no more waters. Let's put the antifreeze ones out. I'm put this a little tighter here. Here's 10% antifreeze, 50% antifreeze. What else do I got? 25% antifreeze, 90% antifreeze, 100% antifreeze, and I think I got one more here, which is, this is 10% antifreeze, 60% full. So that one's testing whether if the level's just above half. I'm going to put the big ones out. Here's 100% water, 90%, 60%, 40%, and I left the 10% inside, I had a problem. I goofed. If you watch the video, I didn't fill it. Here's our two black ones. And so the idea here is make these flat, cover them so UV doesn't affect anything, and watch what happens. Tonight it's supposed to be above freezing. I'll probably come back and put maybe a piece of plywood underneath them to make them sure they're all level, and get my 10% 1.25" pipe out here. Okay, so there we are. I brought out a piece of wood, leveled them all. I do that because like the ones that are 90%, I don't want it to be 100% on one end and 75% on the other end, because that kind of ruins the whole idea. And I brought out my 10% 1.25" pipe, and now the last thing I'm gonna do is cover them. One thing I did want to show you is the wires that go behind it are actually sensors on my fence right there that I connect to an Arduino, and you'll be seeing the chart later, especially when these things start breaking. The recent temperature history was we had a unseasonably warm day yesterday. We had a 60-degree day, January 12th in New Jersey, and we're supposed to go below freezing a little bit tonight, and then tomorrow we'll be in single digits. So I expect some pretty quick turnaround here on some action. Okay, we had our first cold night. It was, I think, about 10. I'll put a chart up. And as expected, the 100% water broke. It's 100% plain water, and the end popped off, and some of the PVC around it broke as well. And you can see the ice there. So that's one down. It's exactly what one would think would happen. Interestingly, the 100% 1.25" did not break, and none of the PVCs with antifreeze in it broke. I'm a little worried that these black ones, they might push the ends out. This end is kind of sticking out here, but otherwise it looks like everybody else is intact, and it was pretty cold. It was close to single digits last night. Okay, folks. This is my pipe project. I covered them to make sure that the UV doesn't affect anything. And let's take a look. Looks like everybody's still intact. It's been pretty warm lately. We've been above 50 several times, even 60 once or twice, but we did have a couple days where it dipped to 10. So I'm starting to think that the 100% is going to be it, but we'll find out for through the rest of the winter. Okay, YouTube, it's February 6th, I think. This has been out here for probably a month at this point. I'm definitely learning something. This guy fell off, but as you can see, nobody has cracked except the first one, the 100% water. Everybody else are fine. Even, interestingly, even the 100% water 1.25" pipe. So far, 100%'s it. Okay, we just had a decent snow. Haven't had one of those for a long time this winter. It's a little unusual. Here's our pipe collection buried under snow. Let's take a quick peek. And kind of as expected, we have no additional victims here. Okay, YouTube, this is a day or so after the nor'easter of 2018. And here you can see my pipe experiment. They're still under there. I can't tell if any more broke, but I highly doubt it. Some of the ones on the end look crooked, but in another day or so I'll return and uncover them and make sure they all survived. I'm not expecting any more to break though. That's it. Okay, there you go. Before I get to the results, I just kind of want to remind you of a few things, right? So this study was kind of a good study, but not a perfect study. And there's always going to be real world things that could happen that could cause you to get damage and incur expense. So for instance, maybe the pipe is under mechanical stress. Maybe it was installed with some tension on it. Maybe you've driven tractors across it. Maybe the earth moved. Maybe there's some seismic activity. Ultraviolet rays will tend to decay plastic over time. So if a part of the pipe is exposed to the sun, it could weaken and possibly break. There might be natural low spots in your pipe based on how it's laid out, and that part might be 100% full where other parts are virtually empty. Animals could chew on it, bite on it, that kind of thing, and there could even be manufacturing flaws. There's probably other things. Feel free to put them in the comments. I'd love to hear them. But, this test is pretty good. I would not, bet lots and thousands of dollars on the outcome. Okay, so what have I learned with this test? First of all, the big risk case is having a pipe 100% full. It breaks easily. It broke the first night. Right, so when the pipe is full, there's water's got nowhere to go, and it'll just push out and break it. Water expands about 11% from what I understand, and when it freezes. So if you're below like 80%, you're probably okay. The more the merrier, but probably enough to go to 5% or 10%. The most dangerous temperature is a few degrees above freezing. This is something I learned from my research. It turns out that once you get past a few degrees above freezing, the water actually shrinks, it contracts, so you're not going to get additional breakage below that. And there's actually a very strange phenomenon with water. It's a discontinuity around freezing, but it gets really, really big, and then it drops suddenly, and then you're fine. But that's where the break's going to happen. Small concentrations of antifreeze make a big difference. I had 10% antifreeze in several of the pipes, and none of them broke when the one with 100% water did. Larger pipes are stronger. I got no breakage on the larger pipes, and poly seems to be really strong. I don't know why the industry isn't generally using poly. Maybe it's harder to work with. But that's it. Feel free to like this video. That'll help other like-minded people kind of find it and use it, and share it with your friends. And feel free to leave comments or suggestions or ideas in the comments. And thanks for watching.